All right, folks, I want to work through a relationship that is going to pretty much drive the rest of this course. Okay, it's going to be the tool that we use almost on every single problem that we see through the rest of the course. If I look at that circle, what is the equation for that circle if it's got a radius of 1? Say again? What is the equation of that circle if it has a radius of 1? Okay, but r would be 1, right? So that red circle, algebraically, is y squared plus x squared equals 1, right? Or x squared plus y squared equals 1, doesn't matter. What's the equation? Now, I know that we don't have a whole lot of detail here, but let's say at this point right here on this line is 1 comma 1. What would be the equation of that line? Y equals x. Okay. Now, this is two equations and two variables, which usually when we have two equations and two variables, we can use elimination and solve for one of the two variables, right? But this is what we refer to as a nonlinear system. One of those is not a line, right? One's a curve, okay? So I'm not going to say you'll never use elimination with nonlinear systems, but your go-to tool for solving for x or y here will be substitution, okay? And that's usually the case with nonlinear systems. So this is an easy one because they're telling me y is x. So can I replace that y right there with x? And if I do that, I get x squared plus x squared equals 1. That's 2x squareds, right? That's x squared is equal to a half, correct? So what's x going to equal? Good. Plus or minus root 1/2, which that changes as we rationalize it, plus or minus root 2 over 2. Is that okay, everybody? So what that tells me right now is that this x value right there, the x value of the point of intersection, because that's what when we solve this system, that's what we're doing is finding where these two things intersect. We're saying that x value right now is radical 2 over 2. Here's another intersection down here of the same exact two equations. That x value would be what? That's the negative root 2 over 2. Now, this is also telling me, once I know that x is, doesn't this tell me what y has to be? Y has to be the same thing. Okay, so that's a little bit of college algebra there, yes? We agree with that? Okay. What is, if I look at the first quadrant, it's 90 degrees, yes? What does y equals x do to that 90 degrees? Cuts it in half. So that 90 degrees turns into this angle here. That is 45 degrees, right? If I'm starting at 0, 0, and I want to get, so I'm just going to call it point A right now. If I want to get to point A, don't I have to travel radical 2 over 2 that way? And then don't I have to travel, once I get right underneath A, travel straight up, radical 2 over 2 that way? And that would be a right angle, correct? What is this thing then right here? 45, 45, 90 right triangle. And my hypotenuse would be n radical 2, n radical 2, where n is radical 2 over 2. If I multiply radical 2 over 2 times radical 2, we get our radius of 1, don't we? Okay. So algebraically, we see that we have a 45, 45, 90 triangle here. And those distances are confirmed or found of radical 2 over 2 and common radical 2 over 2 using the algebra. But we also see the relationship of 45, 45, 90 triangles also confirming the exact same information, right? Does that make sense? Okay. Okay, so here's my next question. Just got to clean things up here, make it a little bit easier. This circle, centered at 0, 0, is symmetric with respect to the y-axis and symmetric with respect to the x-axis, right? Okay. So remember we talked about yesterday, this distance here we called t. Okay. And in this case, if this was 45 degrees, okay, from what we just talked about, right? Okay. What is 45 degrees in regards to radians? Pi over 4. Okay. 45 degrees times pi over 180. That gives me 1/4 pi. Okay. So in the unit circle yesterday, we said this central angle is the same as this distance t out here, right? So this distance t out here is going to be pi over 4. So what I'm going to do right now, and this is going to get messy, so I apologize for that, but there's no workaround to keeping it clean. I'm going to call this t. I'm going to say t equals pi over 4. And the point that is attached to it then let me do it all over. I just know how cluttered things are going to get here in a moment. I'm just trying to make it as clean as possible. So this would be t equals pi over 4. And the point that is associated with that distance is radical 2 over 2, radical 2 over 2. Okay? So, what we call that point right now, okay, is a terminal point that is attached to a distance of pi over 4. Is that okay with everybody? So whenever they ask you to find a terminal point, they're talking about one of these many points that we're going to find here in a moment that are defined by that specific distance that they ask. Okay? One thing that I think is important for us to understand, though, if that's the distance t, this is the angle theta, they are the same. Okay? So, would you guys agree that I can reflect that over here and get a point right there in the second quadrant? Okay. Now, if I reflect it, distance, that's called an isometry. Distances are preserved, meaning that the distance that I took in the x direction to get to this point right here is going to be the same distance in the x direction to get to that point right there. Does that make sense? But because I move in the left direction, it's negative radical 2 over 2. This distance that I traveled to get from 0, 0 to that first point is going to be the same as that distance, right? And they're both positive. Okay? Now what I want to do is I want to ask you this. What would be the t value? What would be the distance attached to that point? What do you think you know about that distance and that distance? They're the same. So this would have been pi, so this distance here is pi over 4, add another pi over 4 to that. That point right there is going to be 2 pi over 4. So add it again, and that's going to be 3 pi over 4. Okay. So now, the next thing I want to do, we can do this all the way around this circle, right? Does that make sense? There's a lot of symmetry that's going to be consistent throughout this entire procedure. In the past, I get people to be confused, and they struggle remembering what numbers go where. And I don't ever want anybody to try to memorize what numbers go where. Can you all count to, let's say, 8? Okay, you can count to 8, right? Okay. Can you count to 2? Okay. If you can count to 2, can you count to 2 by force? That's why I asked you, can you count to 8? If I can count to 2 by force, okay, so 1/4, 2/4, 3/4, 4/4, right? We can do that, right? All the way to 2. So I'd be counting to 8/4, right? Which if I look at the numerators, it's just starting at 0, going 1, 2, 3, 4, 5, 6, 7, 8, all the way through with a denominator of 4, so that's counting to 2 by force, okay? Well, let's look at this. Okay, right here is a point, there's a t value here that is 0, okay? If I count a 4th, it gets me there. Add another 4th, it's 2/4. Add another 4th, it's 3/4. This one is 4/4. Add one more and I get 5/4. Add one more, I get 6/4. Add one more. And then add one more, 8/4. Okay? Now, they should all have pi with them. Okay? And they should all be reduced. So I'm going to come back to this 2 pi over 4. What's that reduced to? 1/2 pi or pi over 2. 4 over 4 is going to reduce to 1 pi. 5 pi over 4, it's already reduced. 6/4 reduces to 3 pi over 2. I already got that reduced, and then 8/4 reduces to 2 pi. Okay. Now, because of symmetry, and I've got these from this point right here, which this is a reference distance, okay, which we'll talk about here in a little bit, a reference number. I can use symmetry to find that point there, right? Can I fold on the x-axis to find this ordered pair here? You guys agree that ordered pair is negative radical 2 over 2, comma radical 2 over 2. And that's going to be negative as well, right? Use symmetry again, take this point, fold, and it becomes that one, right? Okay. Now, my hope is that we understand we're still in the coordinate plane here. Radical 2 over 2 as a decimal is 0.707. So if I want to start at 0, 0, and I wanted to get to that point on the unit circle at pi over 4, I travel 0.707 in the x direction and 0.707 in the y direction, and it puts me on that point, okay? So I just need everybody to remember that we are inside the coordinate plane still, and this point right there is 1, 1. Does that make sense? So everything on this unit circle then is going to be a number between -1 and +1. Does that make sense? Which, if you think about your sine ratios and your cosine ratios, aren't they always something between -1 and +1? And this is the reason why. Oh, that stinks. All right, so now there's also some other points on here that we know, okay? This value of t equaling 0? What would be the ordered pair of that point right there? This point, radical 2 over 2 would stop right here. Because I got to go up, right? 1, 0. It's the unit circle, correct? So if my radius goes straight out to here, that's a radius of length 1. What would... T is from the positive x-axis, from this point right here. It's that distance there along that arc. Yes, so this distance here would be pi over 2. Yes, yes. Circle of radius 1, that's only true for. But we're going to extend that here in a moment and understand and hopefully make a comparison of why we use this circle. What would this point here be? If t equals pi over 2, this would be 0, 1. This one here would be negative 1, 0. Okay. Is that doable? Okay. Now, there is another line here. So we got that line y equals x to demonstrate what this ordered pair was, right? There's another line in here that I could put that would be about right here. Okay. That would generate this angle here to be 30 degrees. But that line, that equation, I don't want to do that substitution. It gets messy. So let's just say, because the previous one was y equals x, we knew we got a 45, 45, 90 triangle here. Here, if this line, whatever that line equation is right there, it's going to generate a 30, 60, 90. And what is this hypotenuse in a 30, 60, 90? 2n. In the triangle that we're working on here, what would that distance be because of this circle? Theta would be pi over 6, or this 30 would be pi over 6. But what is the length of this actual? It's 1, right? We're in the unit circle here. So that would be a relationship that we know true in this triangle, correct? What would n be? 1/2. Well, n in a 30, 60, 90 is that distance right there, correct? What is that? Is that x or is that y? That's a y distance, right? So I'm going to create an ordered pair here, but the y value is going to be 1/2. This is n radical 3, correct? Well, n was 1/2, right? And what was this as a radian? Pi over 6. So this distance here on this arc is pi over 6. That kind of makes sense? And that point right there, so that terminal point for a distance of pi over 6 is radical 3 over 2, comma, 1/2. Is that all right? Can you guys count the 2 by 12ths? Okay, so can you count the 12 by 1s? Okay, so let's do this. If I go just the same thing we just did, 1/6. Now my picture is actually a little bit distorted here, so let me, that's stupid. That point should actually be moved closer to like there. Okay, because 30 degrees is closer to 45 than it is to 0, isn't it? Yeah. Okay. So it's just going to help with the visual here. If that was pi over 6, that would be another pi over 6, right? So this point would be 2 pi over 6. Okay, so that's another t value. And this is where I was saying it's going to get messy. Add another pi over 6. Gets me to 3 pi over 6, right? Add another pi over 6. And you get a t value here. 3 pi over 6 plus pi over 6 is 4 pi over 6. Okay? Add another one. 5 pi over 6. Add another one. 6 pi over 6, right? Which is pi. Add another one. Add another one. But what's 8 pi over 6 reduced to? 4 pi over 3. Okay? 8 pi over 6 plus pi over 6, 9 pi over 6, right? What's 9 pi over 6 reduced to? 3 pi over 2. So 9 pi over 6 plus pi over 6 gives me 10 over 6. But what's that reduced to? 5 pi over 3. Add pi over 6 to 10 pi over 6 and you get 11 pi over 6. Add pi over 6 to 11 pi over 6 and you get 12 pi over 6. I asked you if you could count to 12, right? Those numerals, so if I keep the denominator as 4 and I go around, I'm counting to 8 as my numerator. So keep my denominator as 4, go around counting to 8. 1, 2, 3, 4, 5, 6, 7, 8 for my numerators, right? And that will get me the quarter intervals, okay? If I keep my denominator 6 and then let my numerators go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 12, that's going to allow me to count to 2 by 6s, right? Okay? So that's how we develop these in the unit circle, these positions in the unit circle, okay? Now, let's go back into this first quadrant real quick because there's a t value here. And this, would you guys agree that looks pretty messy? It's going to get messier. There's just nothing we can do about it, okay? But we don't know, so, and I didn't reduce this one. This one is pi over 3. Do you anybody remember how many degrees pi over 3 was? Say again? 60. Okay. Is there a right triangle here where this is now 60 degrees, or pi over 3 radians? Okay. So if this is 1, n would be a half, which would be that distance right there, correct? So in my ordered pair, to get to that point from 0, 0, I need to travel 1/2 to the right. And then how far would I have to travel up? √3 over 2. Okay? And that then is my first quadrant. Okay? Which is ultimately what I think we should, I'm going to say memorize, but not really memorize. Because my hope is that radical 2 over 2, radical 2 over 2, 1, you don't have to memorize that because instinctually you already know it's been beaten into you. You use it so much that you know a 45, 45, 90 right triangle. You can generate that radical 2 over 2, radical 2 over 2 if you need to, right? Okay? We already used 30, 60, 90s enough. Okay? That my hope is that we can find those values. So I hope that this is more instinctual than it is memory. What's the relationship between that point there and that point there? What do you see about the x and y values? They're flipped. If that's A and B, this is B and A, right? What relationship is that? Inverses. Why are they inverses? Okay. What was the graphic that we did at the beginning? What line did we put in there? Y equals x, right? Okay. Isn't this point 15 degrees below y equals x? And this one's 15 degrees above y equals x on the unit circle? These 2 points are reflections of one another across the line y equals x. They're inverse points. Okay? And there's a lot of relationships that we're going to see here in a little bit that allow us to maybe build on that. Okay? But now, would you guys agree that that point pi over 3 is also symmetric to this point right here? Which is, I should reduce that one, that's 2 pi over 3. So then I'm going to put 1/2, but it should be negative, right? So t is 2 pi over 3. The ordered pair is negative 1/2. Radical 3 over 2. Would you agree that this point right here is symmetric to this point here? So we're looking at negative radical 3 over 2, comma 1/2. We now have the first and second quadrant fully developed for pretty much, I'd say, 75% of the rest of the course. What are we going to do with this point here to get this one? Isn't that point right there symmetric with that one? Good. Okay. Remember, all students take calculus, right? Or we can think about every point here is a positive positive, because in the first quadrant, every point here is a negative positive, everyone here is a negative negative, and everyone here is a positive negative, because we're in the coordinate plane, right? Okay. This one here, negative 1/2, negative radical 3 over 2, with a t-value of 4 pi over 3. T-value of 5 pi over 3, that's symmetric to this one here. So 1/2, negative root 3 over 2. And the 11 pi over 6 is symmetric to that one. So radical 3 over 2, comma, negative 1/2. And that is our unit circle. Okay? That is ultimately, the way I view it, it's kind of like a static calculator that provides us with exact values. Your calculator that you have is dynamic. You can change values as you want, right? But it doesn't spit back exact values. It spits back decimals to a precision of like 9 decimal places, which is a problem for a lot of stuff that we're going to do. So we need this tool. And my hope is that we don't memorize. There's a lot of things on there. My hope is that you don't memorize the whole thing. My hope is that you know some relationships that allow you to build the first quadrant, and then symmetry allows you to build the rest, right? You can count to 8, you can count to 12, and should fill in the rest of that entire thing. Question? Yes. Yep. And really, what I wouldn't even remember pi over 3, pi over 4, and pi over 6. I would remember pi over 6. And then the relationship that pi over 6 and pi over 3 are inverses, because that's something maybe I've already got committed to memory and know that just flip-flops the order pairs, right? So it's just staggering those different relationships on that allow you to create this a little bit more efficiently than just trying to say, okay, I know that this number fits that position, this number fits that position. Because if you do it that way, you're going to make mistakes. Okay. So let's talk about what we've really done here. We've created a bunch of distances. So this distance right here is a t-value. We can do that all the way across. Okay. Those are critical angle measurements or distances that we're going to be interested. Pi over 6 is 30 degrees, 45 degrees, 60 degrees, and so forth, all the way around, right? Multiples of 30 and multiples of 45. Do you guys remember talking about in any triangle, and we did some questions with circles earlier as well, that the sine of a particular angle, let's just say theta, was equal to y over r? You remember that? Okay. I'm going to come to GeoGebra real quick. I'm going to start with a circle of a radius of 5. Okay. And I'm going to put a point, just to make things easy, I'm going to put a point at 3, 4. Where did it go? 3, 4. There we go. Put that point there. I'm also going to put a point at 3, 0. Okay, do you guys remember saying, okay, if I look at this angle here that is created from standard position, that angle, it's like 53 degrees here, I think, 53.1301 degrees. If I asked you what the sine of that angle was, Okay? The relationship is that there is a triangle right here that is a right triangle, correct? And if I look at point B, that order pair is 3, 4. So there's your X and there's your Y. What is your R for this triangle, or this circle, or I guess this triangle as well? We said it was 5, didn't we? So the relationship is, and I'm going to pull this up in Desmos because it's just easier to type into that calculator. If I ask you what the sine of 53.1301 was, that'd be in degrees. You see, it gives me 0.7999999, right? Okay. Now, we said it's also y over r. Well, our y value was 4. Our r value is 5. I should get 0.8. So what do you think I should do with this number here to make that 0.8? This is rounded, right? Okay. So the more decimal places I have there, the better, the more precise that will be. Okay. Now, here's my next question. Give me another distance. Give me another circle radius, and I don't care what it's going to be. Huh? 25? Okay. I get that. So now I have that triangle, right? This point E is that order pair right there, correct? You told me the radius here was 25. Okay? If we take sine of 53.1301 and then look at this information here, that we could say the sine of that angle is y over r, be 20 over 25. Does 20 over 25 still give me the 0.8? Okay, so what I'm trying to show you here is if we take, let's see here, circle through radius, and I'm going to let my radius be r here. Okay, so what I've done here is just create a circle that I can change, right? Does that make sense? I just got to go in between 0 and 25. I'm going to ask you to find this intersection point between the circle and that ray. There we go, H. And if I go over here, I'm going to ask it, I don't know why it does that. I'm going to ask it to take the y value of H and divide that by R. And we see that when I do that, it should highlight that number up here, 0.8. Does that make sense? Okay. So are we seeing here, does that 0.8 right here, this I number, does that ever change? No. Because no matter what, I'm getting a bunch of these little red or blue triangles that are all what to one another? They're all similar, aren't they? They all have this 53-degree angle, and they all have a right angle, so they're similar. So the opposite divided by hypotenuse should always be the same. Therefore, if I gave you a circle radius that you get to choose, and you know you have to divide by it, what would be the one value you choose that would make your division as simple as possible? You would make 1 your choice. So if 1 was my choice, then sine of theta is not going to be y over r anymore. Sine of theta is going to be what? It's just going to be y. Well, look at this right here. If I ask you what sine of pi over 6 is, pi over 6 is a theta, right? Look at the y value that goes with pi over 6 for that point t. It'd be 1/2, right? If you take your calculator, type in sine of pi over 6, it spits back the y value of that ordered pair. If you type in the cosine of 7 pi over 6, the cosine of 7 pi over 6, cosine is x over r, right? R is 1. So cosine of theta would be x. So type in cosine of 7 pi over 6. So spit back the x value of 7 pi over 6. That's going to be negative radical 3 over 2. Now the thing is that your calculator is going to spit back like negative 0.866. Decimal version. Approximated. We want to work with the things that we're going to do. We want negative radical 3 over 2. Okay? Your calculators don't work in, it's referred to as surds. Okay? If I'm working with radicals, okay, of different indexes, usually that notation is referred to as surds, S-U-R-D-S. Your calculators don't work, they're not programmed that way. Okay? If you buy a TI-89, or if you're using some of the calculators that are built online, some of those are, okay, but like TI-89 is like $250 for a calculator, so it's kind of silly. So we're going to want this in front of us, okay? And the hope is, so what we go through tomorrow is going to kind of structure the fact that that's messy. I don't want to deal with all that. Tomorrow, what we'll basically do is say, if I only know that stuff right there in the first quadrant, okay, which we've already kind of talked about, I really only need to know maybe those two and some relationships, right? I should be able to answer any question about any angle that is a multiple of 30 or a multiple of 45 from 0 to infinity, or actually negative infinity to positive infinity. And that's what we'll kind of work on tomorrow. No new homework.